Okay, so the database approach. This is our organized method of approaching data. So database are a shared collection of related data accessed by various users. You can have a personal database just on your own computer, but usually you have one that's used for a small business to a large business. Data is organized as records and fields within tables, as we just saw. They're designed to be logical, coherent, and internally consistent. And you'll see that when we get through the next few weeks. The program that we use for the database is a DBMS, or Database Management System. So Microsoft Access is kind of the foundational program that most classes like this use, but there's a lot of other options out there. And usually if you're working for a large organization, you're working with something like MySQL that has far more expansive capabilities than Access. Access is a little clunky, but it's kind of the solid learning one that everyone uses. So databases are a method of managing large amounts of organized data, and that's for storage, retrieval, and manipulation. The manipulation includes sorting the data, summarize it, doing calculations. There's a lot of things that you can do with SQL, but the basic function of it is to organize it and make it where it's easy to grab. Databases can be linked to websites and software, personal file storage systems, etc. You use databases all the time. Like the grocery store clerk, when they scan a item, that little barcode connects into a database. When you go to Amazon and do a search for whatever it is you're buying for Christmas, that goes into, that searches a database for related queries. I even have a database for my books because I like books. So I have a database on my phone listing all the authors and titles, and has images of each of the book titles. So if I go to a bookstore, I don't accidentally buy a book that I already have, because I have so many books, I don't even know what I have. So databases can be used for a lot of purposes, small and large. So it's beneficial for all the characteristics that we were talking about before that the file storage system is not good at. So the way it's designed, it pretty much gets rid of the data redundancy issue, or at least it controls it, which reduces the storage issues, and you're not going to have 3 of the same files laying around, because it'll just be one file somewhere. Changes to data is efficient, and so if, say for example, you have a database for a company and an employee moves, so the mailing address is different now when you mail their taxes to them, like that has to go somewhere else, but also the pay stub has to go to the new location, and the, you know, birthday gift or whatever they, you know, all things that their department does also has to change. You can just enter it one time, it'll fix all the addresses everywhere, instead of that person having to run around to all these different departments. It allows for multiple views or access to the data. So for example, sometimes someone might need a very limited view or limited access, and some people need more access. And we'll get into that a little bit later. Usually that's for data security reasons. Concurrency control strategies allow for multiple concurrent users. So that helps, like with SharePoint, where you don't have multiple people messing up each other's stuff like in OneNote. So that's for data integrity. Data sharing allows for combining information from different systems. So you can just pull the data from everywhere without a problem. And self-describing, this is probably a new one for you, is that it contains metadata, or information about information, or data about data. So an example of this is basically you can tell a field that this is a phone number, it should be structured like this. When people enter the little parentheses, eliminate those, it should be this this many numbers, no alphabetical letters in it. It can tell you that like a zip code should be this length, only numbers, and these are the only values that can be put there. All the websites whining about passwords aren't good enough. Those are constraints that are added into the field. So you can force the data to be the correct format through these different types of integrity constraints. So a little bit more about the metadata. So you've seen metadata all over the place, I can guarantee it. Anytime you open up like a folder system, you can see like the image metadata. The little GIF at the front of my Canvas site is named Dilbert. You can see the last time I modified it, the dimensions in pixels, the size, the date it was created or downloaded to my computer. When you do research, you can see all the metadata on the articles themselves. So you get like the titles, the authors, what journal is published in, all that kind of good stuff, including the abstract. For our purposes, for databases, so the data are the actual things like the names. The metadata is like, so the employee ID number, what type of data is it? It's an integer. A description about it, it's a primary key for the table. The first name, in this example, it's at maximum 50 alphanumeric characters, and it represents the employee's first name. So metadata is important to have for data. It kind of helps make data into information where it gives a little bit more context. It gives information about, it narrows the parameters of it, and it helps make sure that the data entered is the correct data. So that being said, the golden rule of databases is that the point is to reduce data redundancy and increase data integrity. Reduce data redundancy and increase data integrity. That's something that you'll want to remember moving forward about the purpose of databases, but it boils down to it. And wrapping up, databases are awesome. Are they perfect? No, nothing is for free. So what are the costs of having a database? First, you need specialized personnel, people like us who know how to create databases and then maintain it. And that whole installation management thing can be very, very complex, especially depending on the size of the company. I would not want to be in charge of maintaining the databases for Amazon or Google. There's a lot of costs in conversion, there's backup and maintenance, and organizational, political kind of conflicts. So there's a lot of costs, and even just like, if I wanted to input, and I've tried to do this a couple times where I've taken like, oh, I have all these articles downloaded for my dissertation, I'm going to put them into Zotero or Mendeley. Never actually happens because it takes so much time and effort to put all those articles into a database. It's just not efficient enough for me to be able to do that for it to be worth it for me, because I have so many. I'd just rather do it old school and use my file-based storage system, even though, you know, it's good for one-time use and not for repeated use later. So that is the cost of the database.